Okay, today's lesson is 92 areas of rectangles with variable dimensions, products of binomials, and F.O.I.L. Let's just do the last one. Our last objective is F.O.I.L. What?
F.O.I.L.
So let's say I had to tile a bathroom and I had some square tiles. And they're all 1 foot by 1 foot. That's how it adds up to 3 feet. But then I had to cut half of a tile here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 full tiles. I'm going to run out of room if I do that big. Let's try that. So I got 9 full tiles. And then I've got on this side, I've got 3 half tiles. On this side I have 3 half tiles. And then this little guy, he's 6 inches, so he's half of a tile wide and by half of a tile tall. So his dimension, he'd be 1/2 times 1/2 or 1/4. So I've got a 1/4 tile. So if I took my 3 halves plus my 3 halves, that would equal 3 holes. So really I have 9 plus 3 holes, so I have 12 holes, and then a little small guy. So I'm going to show you how to do this with some variables. So I think I'm going to skip this one. I'm going to go right to the variables. If I had, okay, let's say I don't know how wide part of this is, but I want it to be some variable dimension plus 3 more units. Okay, I'm going to call this x. From here to here, this is x. And I want it to be square because I want another x right here. So this is now x by x. But I need 3 units to go across here, so I'm going to divide this in 3 units. This has got to go all the way down, continue that down. See if I've got 3 1-footers down there. And then on this side, I'm going to do a plus 2. So I need 2 across here. So I'm going to divide this in half. So the question is, if I were to add up all these pieces, what's my total area? Not knowing how big the x portion is. It's a variable portion. Well, I know that length times width would be x times x, or x squared. This is 1 foot wide by x long, so it would be x times 1. So my area is x. What's my area? Get ready?
X.
X. Same thing for this, same thing for this. Let's look over here. This guy is 1 foot wide, but he's x long, right? So it's 1 times x, or x. What's my area? Get ready?
X.
Same thing for this guy. So now so far I have x squared, x plus x plus x, another x, and then these guys are all 1 by 1, right? It's 1 square tile. So I have 1 full, 1 full, 1, 1, 1, and 1. So all together I have x squared plus x plus x plus x. I have 3 of those x's. I have 2 of these x's. Oops, plus 1, 2, 3, 4, 5, 6. 6 holes. Again, I don't know what x is, but I'm leaving that as a variable dimension. Add like terms, 3x plus 2 x's. All together I have 5 x's plus 6 holes. And that is the overall area of this figure with variable dimension. Let's look over here. Okay, this one's kind of nice because I like the colored units. Let's check. If this is 1, 1, 1, and 1, what's the area of this rectangular piece? Think. Get ready?
X.
X. Very good. Same across?
Yes.
All right, x, x, x. If this is 1 wide and x long, what's the area here?
X.
Get ready?
X.
X. Same thing there. And these are all 1 by 1, so this is 1 hole. It's the same problem almost. So if I were to add all this up, I'd have x times x, or x squared. Plus I have 4 x's here, and 2 x's here. See how they're color-coded? And then 8 holes. And then, again, it's combined like this. So then I thought, gosh, it's a lot of work to draw this and, label it. Could I find the area of a variable length, x plus 4 and x plus 2, a shortcut way? I don't even like to use the word shortcut. But could I use a math method called, let's do this. show you how to multiply length times width without drawing it. And it's pretty cool. Okay, we call it FOIL. What do we call it? Get ready?
FOIL.
FOIL. It's an acronym. First, outside, inside, last. F stands for first. What?
First.
First. What it means is I take my first term inside each parentheses, which would be the x and the x, and I multiply them just like I did right there, x squared. Okay. O stands for outside. What does O stand for? Get ready?
Outside.
Outside. What that means is I take, in my two parentheses, I take my outside terms, the x and the 2, and I multiply them. So I get 2 times x, and I always draw an arc so I can keep track of, oh yeah, these are my outside ones. Okay. Did I do that down here? Did I have 2 x's right here? Perfect. All right, so now let's take, red. Now, I stands for inside. What does I stand for? Get ready?
Inside.
Inside. So I'm going to take the inside terms of my two parentheses, these guys, 3 and x, and multiply those guys. And I add everything together, but I multiply and then add each term. Then, L stands for last. What does L stand for? Get ready?
Last.
Last. So I take the last term inside each parenthesis, 3 times 2. Now, did I do a 3? Do I have 3 x's here?
Yes.
And do I have a 3 times 2? Here's my 3 across by 2 wide for my holes.
Yes.
It's kind of cool. It maps my two binomials using FOIL method exactly what we did by adding those up. So now I'm going to combine like terms. What's my next step? Get ready?
Combine like terms.
Combine like terms. I have 2 x-rays plus 3 x-rays. Altogether I have 5 x-rays. And then 3 times 2 is 6. Nothing else is like. Do not add anything else together. They are unlike terms. You're done.
Wait.
So that is called the FOIL method. What is that called? Get ready?
That's it?
FOIL method.
FOIL method. I have lots more examples to show you and let you guys work on some, and I'm going to call on people to help. Annika.
I'm confused on where the x plus 3 and the x plus 2 came from.
Oh, very good question. It says a rectangle is x plus 3 units long and x plus 2 units wide. Find the area. Good question, Annika. Joseph?
What does the L stand for again?
Last. Okay. First, outside, inside, last. Let's try a couple practices. We already did that one. Okay, x plus 3 times x minus 4. Using the FOIL method. FOIL, F stands for, think. What does F stand for? Get ready?
First.
First.
Oh, yeah.
Okay. We'll write it out. FOIL. First, so x times x is x squared. Next is outside. What does O stand for? Get ready?
Outside.
Outside. So I'm going to do the outside terms. X and, wait, is that 4 or negative 4?
Four.
Negative 4. Okay, negative 4. Keep the negative with it. X times negative 4. I like the coefficient in front, so we're going to write negative 4 times x. Next is I for inside. What does I stand for? Get ready?
Inside.
Inside. I'm going to switch over. I like to do the inside and last on the bottom. 3 times x. Next is the last term, L. L stands for last. What does L stand for? Get ready?
Last.
Last. So I'm going to do 3 times negative 4. I add everything together, but 3 times negative 4. Keep the sign with the 4. So now I simplify. But my like terms are in the middle. Negative 4x plus 3x. How many x's do I have? Think. Avery. Okay, let's get some help from Sophie. Negative 1x, right? So negative 4 plus 3 gives me negative 1x. All right, give me 3 times negative 4, Avery. Negative 12, good. And then I'm just going to clean up my last step, make it as simple as possible. Negative x minus 12. So that is these two binomials multiplied. It's kind of like the distributive property, but you have to distribute everything. I like to use my fingers when I do it. First, outside, inside, last. Let's say it together. Ready?
First, outside, inside, last.
And I always draw my arcs so that I can keep track of which parts to do. Okay, your turn. X minus 2 times x minus 1. Write it on your notes. Put your pencil up after you have used the FOIL method. Okay, very good. I checked tons of you. I didn't get to everybody, but I saw lots of right answers, a couple of not quite right answers. I'm going to slide it up a little bit so we can work it through. All right, tell me what you did. What was the first thing you wrote down, Connor? After you drew your arcs.
So I did x squared plus negative 1x.
Negative 1 times x. Excellent. Let me get some more helpers. Joseph, what did you do next?
Plus negative 2x.
Very good. Plus a negative 2x. Good. And then what?
Plus
You're in the last terms, right? Your L for last.
So then it's just
Negative 2 times
or negative 2 times
negative 1. Okay. All right. My next step is simplifying. Addison, help me out. What did you do?
So negative 1x and negative 2x go together and get
Negative 3x. Yeah, I didn't really need that plus sign there, right? Because the negative's going to override that anyway. So I have negative x minus 2x. I get more negative. Okay, I'm going to copy down this. Do I need a plus, or is the negative going to override the plus anyway? So it's okay if we just say minus. And then I've got plus. Negative 2 times negative 1. What does that give me, Rachel?
Sorry, what? My mind just went blank. Negative 2.
Close. Negative 2 times negative 1.
Positive 2.
Positive 2. And then nothing else will combine. That's all you get. Raise your hand if you got x squared minus 3x plus 2. Excellent. Very good. You guys are doing awesome. All right, what happens if they threw something like this, where it says expand x plus 4 squared? But wait a minute. I thought the FOIL method you'd have to have 2 pieces for. Winry?
Since it's squared, it's just x plus 4 times x plus 4.
Excellent. X plus 4 times x plus 4. If you want to use your fingers, x squared plus 4x plus 4x plus 16. Combine like terms. There's your 8x, and you copy down their x squared plus. I know that was a super fast example. I got one more for you. Do x minus 3 times x plus 2. Copy it down in your notes. Put your pencil up when you've got it. FOIL that out. We sometimes say FOIL it out. Okay, let's see how we did. Liesel, what did you do?
I copied it down and then did the arches.
Okay.
And then I put down x squared plus 2x
Okay, perfect. Keep going.
minus 3x
Perfect.
minus 1.
Your last term to check that one is going to be a negative 3 times 2.
So negative 6.
Yeah, negative 6. Okay, good. What was your next step, Hannah?
Then I did 2x minus 3x equals negative 1x.
You can't really do anything else, can you? All right. Nothing else is a like term, so you're done. X squared minus x minus 6. How many of you got it right? Excellent. Okay, that is it for today. We're going to do some practice problems on 620. Take a 20-second stand-up break.